So, ladies and gentlemen, I'm very happy today to introduce you the very first time the Nova talk for cellulose fibers. And today we will talk about Next Generation Lyocell, Textile Sustainability and Circularity. And we from Nova have been talking about cellulose fibers, introducing it to a broader audience with a conference since 5 years. And today we put another possibility on the market to talk about cellulose fibers more often. And it's a modern possibility to put a spotlight on different kind of topics. So it lives with a sponsor who's helping us to put it in the market. And then this gives the possibility for the audience to step in for free so we can reach a larger audience for different kind of topics. And today, my name is Asta Partanen from nova-Institut. I'm expert for cellulose fibers and different kind of natural fibers, wood, renewable materials. And I'm very happy to introduce you our first speaker and sponsor, and his name is Manuel Steiner, and he's coming from Switzerland from the LIST technology. And with him together, we have Philipp Köhler vom Thuringian Institute für Textil- und Kunststoffforschung. He's also a distinguished expert of cellulose fibers, and he will also talk about the cellulose fibers today. And without our media partner Claudia von Bonn, I think we wouldn't have such a big audience. And I can tell you already that we have 240 participants today. The next one, please. But before that, I, of course, also want to introduce to you the nova-Institut. So we are not only giving different kind of conferences and online formats, but we are a private research institute and have 4 different departments in which we are helping the industry to get rid of fossil resources. And fossil resources can be replaced with bio-based resources, and cellulose fibers are, as you know, also bio-based, and of course also CO2-based resources, CO2 from the air. And of course, recycling is also a very important part of the play. The next one, please. And the recent conferences that are not only online, but also taking place in person, maybe something interesting also for you, the Advanced Recycling Conference. There we will also have a session for textile recycling. So hope to see you there. It's already next week. The next one. And this format lives from discussion. So we don't want to give you too much presentations. We want to give you a discussion with the experts. And not only me is asking the questions, I will be busy looking at your question at the chat window. So you see now the slide with the chat window, so you can already start saying hello there and saying I'm here. And afterwards, then when the discussion starts, you can put your questions already also when Manuel will talk about and present his company. So you can also move the slide bar there. And I think Manuel should be first giving the presentation. So excuse me, Lucica?
That's correct. So Manuel can take it from here.
Yeah, so Manuel can take it from here. So I'm very happy to introduce you Manuel from LIST, and he's an important technology provider for the lyocell technology. So Manuel, the stage is yours, and we want to keep it short, and I will take time, and your time is starting now.
Thank you, Asta. You can see my slides?
Yes, it's perfect.
Okay. Yeah, so thank you, Asta. Thank you to the whole team of nova-Institut for arranging this webinar and giving us the chance to talk about lyocell. It's one of my favorite topics. And my name is Manuel Steiner. I have a background in engineering and business, and I'm heading the business development of LIST. LIST is a high viscosity technology provider, specialized in dealing with not free-flowing, so tricky materials like sticky materials, crust-forming, phase-changing materials, but also, of course, then the ability to deal with large amounts of high viscous materials, which brings us into several industries, such as the rubber industry, where we do the direct devolatilization of rubber solutions, or we provide technology for polymerizations, which brings us in the polymer industry, or also other fiber industries like the dissolving for aramide, or also Kevlar. Then the chemical industry for the drying difficult materials, recovery applications, food applications, but also recycling. And at the end of the day, we provide then, the goal is to provide the equipment for world scale solutions. Such equipment may look like this one, which you see here. We built them up to 15 cubic meter in size of process volumes. And they have a working principle which is as follows. It's always a horizontal large volume of housing with an agitator, which is equipped with devices which can handle highly viscous materials, which interact with counter elements which are mounted to the wall, and we feed this equipment on one end, then we fill it partially, and leaving a gas space, and then we mix it and enforce a surface renewal of these difficult materials at low shear, and even enabling a evaporation of a volatile phase so that we can do thermal separation processes as all the surfaces are heated or cooled. And then we discharge the rest at the other end of the equipment with a extra discharge device, which decides about the time of how long the product stays in the equipment, so the so-called residence time, which is about 5 to 60 minutes. And we do that all in a continuous operation for, as said, highly viscous, also the solidifying products, compression sensitive, and even textile shreds. So in other words, it's operational wise, it's like a continuously stirred tank reactor, which over time has developed high viscosity capabilities. In order to design a specific machine for a specific customer specific product, we run test centers in Switzerland and South Korea to go through these very specific solutions. And if you are interested to have this processing capability also for in your lab to develop your recipes, we have designed a downscale, or you can buy a downscale reactor in the lab, which fits in a fume hood. And more information under this URL, which you see here, at least-labnieder.com. When it comes to lyocell, or dissolving cellulose fibers, we provide the technology platform to dissolve cellulose from any type of biomass with any type of solvents, where we take it from lab to world scale. In terms of lyocell, you see here a traditional classic value chain where you start with dissolving wood pulp. So you make a pulp from trees, and then you make a spinning solution, and then from the spinning solution you make fibers. Now, if you take this value chain and you apply it to pulp from recycled textiles, then you have some limitation, which means that you can only blend in this different pulp into regular dissolving wood pulp, so that that used up to 30%. This means that you still need the double amount of wood pulp in order to recycle recycling pulp. now that's how LIS comes into play, as we have technology which you can add on to the existing line, as you see here, and then this allows you to to unlock your limitation, and you make actual lyocell from 100% recycling pulp, which is also then the key technology for a vertically integrated plant where you have a fiber line after the pulping. And with this technology, it prepares you also for any other grades like pulp grades like pulp from hemp, which is also another trend. So if you'd like to know more, you find here the URLs, and I look forward to answer your questions. Thank you.
So, and now I think Philipp is going to take over.
We see the slides perfect, Philipp.
Yeah. So go on, Philipp.
A warm welcome from me too. My name is Philipp Köhler. I have a background in materials engineering, and I have been working at TITK in the field of cellulose since 2014. And within this time, I completed my PhD in engineering in 2024 and have been head of the native polymer and chemical research department since 2023. Yeah, today TITK is a materials research institute with a long history in the field of fiber materials, but also polymers, and work in the field of cellulose at the site dates back to 1935, when one of the first viscose plants in Germany established here in Rudolstadt. And yes, one of the main areas of research in this field of pulp evaluation and pulp processing into fibers using the lyocell process. The lyocell process as a direct dissolution process for cellulose is characterized by the fact that only pulp and the solvent N-methylmorpholine N oxide in combination with water are used to produce lyocell fibers, and that up to 99.5.7, depends on the scale, of the solvent can be recovered and reused in the process. Next to NMMO as solvent for cellulose, we also experienced in use of ionic liquids. Yes, and current task at TITK in this field is the evaluation of wood-free pulps, like from agriculture waste or waste textiles, and their use in the lyocell process. We use a dissolution technique that not only make it possible to process up to 100% wood-free pulp, but also to produce permanently functionalized lyocell fibers. We have an excellent and extensive equipment at our disposal for this purpose. We can do comprehensive pulp and spinning dope characterization. And for the processing, we have 4 scales available to processing the dope and evaluation the spinning behavior and evaluation the fiber properties, and including 2 scales on which fibers can be spun continuously. And for that we use kneader technology, which give us good controlling of residence time of the spinning dope for a better dissolution behavior, especially for wood-free pulps. As the topic of textile recycling is becoming increasingly important for us too, we established our innovation center last year, the so-called DICE, Demonstration and Innovation Center for Textile Circular Economy, where we want to make an active contribution to transferring the textile industry from a linear to a circular economy. Important for us is that we use all streams of materials arising during this processing, and this should be processed into new products in line with the principle of upcycling. For that DICE, we have received 8.5 million euro in funding from the state of Thuringia, of which 4 million euros will go to the construction of a new technical center and 4.5 million euro to the purchase of new equipment. The largest investment will be a 650-liter pulp digester system and a depolymerization pilot plant for polyester. And in addition to demonstrating the feasibility of utilizing agricultural waste or residues for pulp production on a pilot scale, the central task within this DICE topic will be the development of new holistic recycling technologies for textiles. Yes, that's all for now. Thank you very much, and I'm looking forward for the following. Thank you.
Yes, Philipp, thank you so much. We will discuss further after we have heard Claudia presenting the textile technology and helping us to spread the word about this different kind of technologies.
Yeah, that sounds perfect for me. Thank you, Asta. And a warm welcome from my side, of course. My name is Claudia van Bonn, and I have a background as textile engineer, and I'm the editor-in-chief of the Textile Technology Trade Media brand. I'm really happy to attend the first NOVA Talks because I really think that this dynamic format is a very interesting experience for all of us. I hope. So let's see, I hope. Our Textile Technology Media brand is part of the Deutscher Fachverlag Media Group, and today we are one of the largest independent business media companies in Europe. Altogether, we have approximately 100 trade media covering around about 70 key industries. Our umbrella brand of Textile Technology is our umbrella brand, and is for the media technical textiles with non-woven strands and Meliant and Man-Made Fibres International. Every brand has its own homepage, and all together we inform about the whole value chain from fibers up to technical textiles and non-wovens. Our print portfolio includes 3 publications you can see on the slide. We have Technical Textiles, Meliant, and Man-Made Fibres International. Technical Textiles is in German and English for all topics related to technical textiles and non-wovens, and it's published 5 times a year. Meliant is also published in German and English with all topics from fibers up to spinning, weaving, knitting, and textile finishing, and we have a focus on recycling. It's published 6 times a year, and then we have Man-Made Fibres International, which is in English, and it's for the global man-made fibers industry, and there we have a real strong focus on recycling. As you can see on the slide, every brand has its own homepage, and we publish 4 newsletters a week that are free of charge. Yeah, that's all I want to say. Thank you very much, and I'm looking forward to this new format combining information and interactive discussion, and then it's an exciting topic, Next Generation Lyocell. So be inspired, stay informed, and yeah, with us you are updated. Thank you very much.
Thank you, Claudia. Excellent. And now we can already move forward to our discussion about cellulose fibers. We from NOVA has been branding this word cellulose fibers for different kind of cellulose fibers, modal, lyocell, you name it, because we think that the end customer needs one word as cotton, for example, that they understand that it's not something different if you talk about viscose or lyocell. Of course, they have differences in properties and so on, and Manuel will shortly tell you more about that. But I would just would like to really engage you to go for the word cellulose fiber as a generic norm. So, Manuel, we have already a lot of questions for you, and the next slide will bring us already to the topic of Next Generation Lyocell. And there was questions about your process and why it is not possible to put more as 30% recycled fibers. Maybe you can do a little bit elaborating. What does it mean, the next generation lyocell fibers? Your microphone, Manuel.
So, yeah. Good. Can you hear me now?
Yes.
Yeah, thank you for this. That's for the key question. It's the, well, next generation lyocell refers to it's a summary term for all the developments which are currently going on. And there are many drivers actually. On one side, all the circularity requirement or desire, then also the increase of the sustainability, and which is actually with the desire to make more cellulose fibers. Right now, cellulose fibers they cover about maybe 8% of all fibers worldwide, and it's maybe about 1/4 of only 1/4 of the amount which is of cotton. So it's only a minor portion. And it's the main driver of this, or the reason being for cellulose fibers, so are man-made, our man-made cellulose fibers, is the so-called cellulose gap, which means that the cotton areas are limited, and there is a need to, and there's on the other side the desire for having cellulose type of fiber. So cellulose fiber is a replicate of cotton. And because this can be breathing, and so it kind of soak moisture, is easier for comfort to wear. The problem is that, of course, it's right now made from wood pulp, so it's basically from trees. And so from that point of view, it is biodegradable and it's renewable, and but it's still from amount still, of course, one portion of cotton. And there are many attempts now making novel lyocell, because on one side there is this from the recycling requirements and the circularity desire. There is these huge amounts of recycling of textiles, cotton textiles, which somehow need to be recycled, and that there is a certain pressure for also making lyocell from alternative biomasses from this. And on the other side, there's also the question, where this, if you really need of the raw material, if you need all this wood pulp, because the wood trees is also sometimes also it's actually green, and I think they're also sustainable trees. On the other side, there's still a desire, also ideas to use different biomasses, for example, agro waste, as a biomass. And there is the same, and one of the very, the known or the biomasses is hemp. And it's also the same question, how to make lyocell from hemp. And there are the more, let's say, very, more technical questions, which I think Philipp will be the better person to explain the details. But in a nutshell, they all need more mixing intensity. And that's why this is what our technology, that we find out that we have there a processing capability which is actually which is really useful, or which is needed, and that's our access to this. So basically, in a nutshell, alternative biomasses need more mixing intensity. That's why I list technology, and that's why also we work closely with Philipp.
Mm-hmm. Philipp, maybe you want to tell something about what's really the difference in your hemp-based lyocell materials, because there are questions about that.
Yes, the main difference is the source, of course, and depending where the raw materials come from, the properties of the pulp or the raw material is different, and you have to look, especially when you use the standard solvent NMMO for lyocell, that the pulp properties fulfills the requirement for the lyocell process, and that's very crucial, because while using NMMO, you have to look for the thermal stability, or the stability itself of the solvent, and that makes the whole thing very difficult.
But Philipp, isn't it afterwards the same fiber, lyocell fiber? What about the fiber properties at the end? Should it have the same properties as a wood-based lyocell fiber?
That depends also from the pulp properties itself of the macromolecular level, which means if you use a pulp which has a very broad distribution of the molecular weight, then you get fibers in the common sense of lyocell. But if you use a pulp, especially when it comes from cotton or from hemp, then this distribution it's much narrower, and therefore the fibers you get from it can have a higher tenacity, for instance, which make them more suitable for technical applications. So yes, you are right. In principle, a lyocell fiber is always a lyocell fiber. It's cellulose, and the properties are almost the same. But depending on the used source or raw material, you can achieve better or other properties compared to a standard wood-based lyocell fiber.
There's also a question about using other natural fibers like jute for it. Did you test something like that?
We are working very closely together with another institute in Tarant. They did a lot of investigation regarding different raw materials or other annual plants, things like that. And there are some agricultural residues that are more suitable for pulp for the pulping process than others. It depends on the efficiency, how much cellulose can you extract from a plant, but also other things like how much is the content of metal ions inside. When they are too big and you need too much effort to reduce them, then you damage the polymer. Then so the plant is not so suitable for pulping and therefore also for lyocell. But yes, our partners did a lot of investigations in this region or in this area, and we participate from this results, and we're working closely together and show in the past that also other or pulps from other resources are suitable for lyocell.
Yeah. So
maybe I can add here. So, but I think that overall, if it's okay.
Sure.
please do so.
Basically, what Philipp said, I think that's a fascinating part from my perspective. Basically, what we say is you can take textile waste, you can make agro waste, and you can make a fiber with higher tenacities. I think that's wonderful. And that's why this is a motivation for me just to pursue that. Yeah. The other thing, what maybe also, Philipp, how about the ILs? I know that you mentioned now the NMMO, standard lyocell is using NMMO, where we have this thermal degradability. That's, it's metal content, there's a safety aspect, but with ionic liquid, you don't have that problem there.
Yeah, that's right, Manuel. But during the process, there is accumulation of metal ions and other things like that. And up to now, there is no purification process known for ionic liquids. Nevertheless, which ionic liquids it is. But yeah, ionic liquids itself, they have a huge potential because the dissolution power is very good. You can dissolve in a faster time. You can dissolve with higher solid concentrations. But if you can't use the solvent again and again in a closed loop, that makes it unusable in a commercial scale. And so we have to find a way to recover the solvent and also clean it from purifications like impurities, like metals, because this accumulation maybe leads to an accumulation also in the fiber with the time. And maybe this leads to another problems in the textiles. So it's also a problem for the ionic liquids.
Okay, I think we will move forward to the next topic. Keep keeping us the questions, please. The big problem is that since a very long time, the share of synthetic fibers has been increasing, and with that, of course, the microplastic. And today we have a huge share, over 70% already on polyester. And we would like to have more sustainable fibers there. And the only fiber who can do that is the cellulose fiber. It's because it's possible to scale up quickly. Of course, there are these best fibers like hemp, but the technology is not possible to make that so quick that we get a scale up in time. We need desperately more to fill the cotton cap, because the cotton is not going to grow more. And of course, also the cotton has some sustainability problems, and also the certification of sustainable cotton is not moving forward as quickly as it would. So if we look at this big picture here, how do you see, Manuel, here? How can here the lyocell help the big picture?
Well, from a big picture, lyocell, as said, is let's say it's a man-made fiber, so it's synthetic cellulose fiber, and from that point of view, yes, it's scalable. It's actually it has already started. So all the new capacities of man-made cellulose or cellulose fibers have been lyocell during the last years, and it started, I think, when it became part of the 5-year plan in China. After the first award is the established companies in the fiber producers, which used to be viscose fibers. Then they started with lyocell, but then it's about five-ish years ago, it's really started. All the new capacities for cellulose fibers have been lyocell and has been in China,
Yeah.
and or in Thailand, so in Asia. And this has been lyocell. There are not new lyocell viscose plants due to the, I think there are several issues why lyocell. So from that point of view, yes, it has already started. Now the question, why lyocell? It is, first of all, it's sustainable, as Philipp explained. There's this closed loop, and it's also safe for the environment, also safe for the workers, and it is recyclable. Viscose is not recyclable, so the lyocell is recyclable, and I think that's the big plus for lyocell. So that's the right direction we go there.
Lucica, can you change the slide, please?
But maybe one comment from my side to the previous slide. Yes, indeed, Manuel, all right. With lyocell, you can do this recycling. You can take cotton and put this cotton in the lyocell process and get a lyocell fiber from it. But you can do this also with the viscose process. But the main difference is with the viscose process, you can do it just one time. After that, when a fiber is a viscose fiber, you don't have a chance to bring this kind of cellulose again in the viscose process or in the lyocell process due to the molecular properties. But with the lyocell process, they didn't harm the polymer chains that much, so you can do this recycling, use cotton, make lyocell from it, cut the lyocell down and use it again in the lyocell process. You can do this many times, much more often than compared to viscose. Just saying.
Yeah, thank you, Philipp. There's a very important question about the prices. Can one of you say something about the prices of technical lyocell fibers? Because as you know, you can use, of course, the lyocell fibers also for technical applications, not only for textiles. You can use them also for composite materials. And there's one person who says, Paul Riesen, he says that the prices have been rising massively. Do you have some ideas about this development?
Yeah, first of all, this is due to the classic economies of scale, I guess, because when you or when the production capacities will go up, then the price will go down, and we are just at the beginning of this journey. And another point is when you try to use pulp, which leads to high tenacity fibers, for instance, there are not so many players in the world who can process this pulp. So this is also for us, for Manuel and for me, a good starting point at the moment, because we can now form the future in this direction.
Maybe in addition to what Philipp said, I think the question was about technical fibers for lyocell. So right now, I don't know exactly what this means, what this refers to. If this question refers to filament, there are basically no filament lyocell on the market, only specialty, and then of course it's very expensive. The other thing in terms of prices, it's interesting to see that lyocell prices are not, they're even closer, approaching even close to viscose prices. And this has also to do with the fact that on one side, after all these lyocell plants came up, also some viscose plants, in particular minor viscose plants, have been closed. This means actually the overall capacity of viscose is smaller, which increases the price, of course. And on the lyocell, it's the opposite. There's many new plants which have been out there, and maybe not yet the demand which is there. So I think that's also, we see here some, let's say, the fluctuations due to the change. So we are far away from a steady state situation.
Manuel, I think we should go to the recycling part of this discussion, because there have been a lot of questions already about the recycling. One question is also using lyocell in personal hygiene products. Are there ways to compost or recycle? What is the best end of life back to the start of lyocell in lyocell process? So can you tell us how we can best use
it's basically the lyocell needs to be collected. Actually, we don't collect lyocell, we collect the textiles made out of lyocell. And which opens a big topic. So we have we just at the end consumer, we just need to collect these textiles, and then they will become part of the overall circularity. And then there are these collecting companies. Then there will be typically also then there's the sorting. There's a lot of companies and technology out there being discussed how to sort it. So these sorters actually can identify the type of garments and the textile. They can identify if something is purely cotton, if it's a mixture of cotton and polyester, or a mixture of cotton, polyester, polyamide, whatever. This can be detected, and then it's sorted, and then there will be then sorted amounts of waste, or textile which can then go to the individual recyclers. The problem is that right now there are not that many not that many recycling capacities. Now the regulations which are out there to push, and there are many projects and customer that startup companies doing that, and some of them have also now could raise money in order to go for a first industrial plant, but there's not that many there which can really fulfill all the recycle all the material which is collected. But to answer the questions, as an end user, collected a textile and put it in the textile collection bag.
There's a question for you, Manuel. What does Manuel mean? Is textile waste 90 million tons a year, or what is that figure? Yes, that is the textile waste. That is the textile waste.
Well, this is not my figure. This is a figure from Asta.
Yes, it's not Manuel.
Wanted to motivate. But yes, this figure, this 90 million ton, refers to an estimate of textile waste, global textile waste, and where about so about 50% is actually not pure cotton; it's somehow mixed. And when you do a closer look, actually reduces this number a bit. So from the 90 million, our number is 105 million tons of textile waste. There's not everything is actually then collected. So which from 105, let's say about 1/3 about is lost. Is not really and is not collected, and then reduces this number. So the number, I take my number because I noted them here. It's 105 million total waste. 70 is collected, and about 55 million ton is ready for processing. The difference between the 70 and the 55 is the reuse, and so this means which goes into second-hand clothing. And the numbers are actually, it's difficult with these numbers, by the way. It's very difficult to have numbers. There's a website, it's called World of Waste, which is, I think, which has a lot of information about that, and I would suggest also then to use to get data from there. The other thing is then when it's about cotton, since we are talking about cellulose fibers, we need the cotton fraction or the man-made cellulose fibers fraction. And the question is, if this, how many, if these, is of course the difference if you have a garment which is only from cotton, has no fibers, polyester fiber in there, has no elastane in there, that's much easier to recycle than if you have blends. And I think that's what you're referring to here. And it's not that easy. I'm not aware of any data from a global scale. There is data around from France. France made once an analysis about how this what can you find in the collections, and they came up with about 25% of what has been ready for recycling, which is pure cotton. And then about 10% is cotton, polyester, all the rest, and 10% is pure polyester, and the rest are blends. And this is really, it's much more difficult to recycle. This means a recycling plant also needs to be adjusted. Is it now then you have different technologies, and each fraction which you have to take out. So if you would like to recycle blends with polyester, you need to have a process step which can deal with this polyester fraction. If you recycle pure cotton, you don't need that. So this makes, of course, recycling much more difficult the more blends you have. And so that's why a closer look makes it a little bit more, and it says yes, but where it gives you a more differentiated answer. But anyways, if you take this 25% of pure cotton, and let's assume that whatever is in France applies to a world scale plant, then this would still mean that we have about 12 million ton of pure cotton textiles. And 12 million is about the double amount of the volume which you have a cellulose fiber. So if you make cellulose fibers from this additional recycling pulp, then you can add the double amount of current cellulose fiber production, which means you can triple it. So which is a huge potential, and basically you have to process this. Imagine you put regulation in place, people need to collect it and sort it, and then nothing happens. This will be also from a general acceptance point of view a problem. So that I think there is also a certain social responsibility of the recycling industry to do that.
Yeah, and of course we are going to have in EU regulations in place where the responsibility for the producing companies is there to take care of these textiles. So this will come, and we will have them. We have this as a resource. Maybe we step.
Maybe just one add with Mr. Nix, just sorry to say that, but with referring to textile waste, I said it's difficult to have this to recycle the blends. But the first and there's a company called CIRC, which has money approved for which they are now building a 70,000 tons recycling plant for polycotton, so for blends. So they're really actually identified as a market, and they're going to do that. So it's a good example, and it's which makes hope. Yeah.
Mm-hmm. Yes, but you should also answer the question about the lyocell to lyocell. Is the recycling from lyocell to lyocell possible? How can we really close the loop here?
Yeah, it's lyocell from lyocell can be done. As said, it can be, since it is a so-called physical dissolving. It maintains the polymer length and doesn't shorten them. That's why you can also recycle it. It's proven that experiments prove that you can 5 times recycle it. So assume the 12 million tons, which we mentioned before, you can recycle that 5 times. Then you have a powder, and it's 5 times 12. You have a raw material amount of 60 million, which is already more or less the raw material in order to replace, which is equivalent to the fibers of polyester close to. So that's that's why lyocell. How? You need these recycling plants, need the pulping plants, which can make a pulp, dissolving pulp from these textile plants, and the technologies are out there. The companies are, the startups are there. The first the company is in operation. Is Circulose, and the second is now with Circ. These are the biggest one. When we are talking about chemical recycling, by the way, there are also the mechanical recyclers. They maintain the cotton fibers itself. They don't make pulp. They maintain the fibers. The problem there is that typically recycling means to shorten the fibers to more or less, which means that you're limited in terms of recycling it because you shorten the fiber length.
Yes,
so that's what I comment.
Manuel, excuse me.
Yeah.
There's also a question about the purity of the cotton. If you have all these additives and all this coloration on it, do you have problems then to use this for your technology for lyocell, or even at that's normal recycling, mechanical recycling from textiles?
I suggest that Philipp may be in a better position because he sees that he's involved in many of these trials.
Yes. Yes, Tatjana, a good question, and you are indeed right. There is no pure cotton outside. There are always dyes, also different composition of materials, finishing chemicals such cross-linkers, or oil and water repellent impregnations, or other textile auxiliaries. But this makes the whole recycling topic so huge, with many unresolved challenges, and we have to solve these challenges, and that's why are we here and talking together and establish the dyes to address to all these problems. And we saw, especially for the textile recycling, which means use cotton, when the producer use crosslinkers, especially, you have no chance to dissolve this cross-linked cellulose because it's cross-linked, and that's a huge problem. And you need new ideas. How can you decross-link the polymer, or separate the cross-linked part from the uncross-linked part? And yeah, you're totally right.
I think the question is also, now there are also technical solutions for those, but they're maybe not so cheap because it takes a lot of effort to clean them out, such as a cross-linking cross-linked fibers. The other part is that there are also voices which actually request that there should be not all to regulate, somehow trying to regulate. And by the way, I'm not a friend of regulations, but anyways, to somehow to reduce the amount of possibilities with these mixed textiles. It's just because if you have very specially, since the recycling needs to be specific to a particular blend, and you have a whole range of blends, then at one point it does not become economical. So you can, as I said, everybody right now goes for the unique, for the 100% cotton textiles. I would say there is a race for good waste. Everybody is racing for the good waste, and then a big portion of the textile waste is not wanted because it cannot be dealt with yet. And so that's why then the play. There's now then the second ply with Circ after Circulose. Circ is already dealing with polycotton. And I don't know how about their specification, probably also remains to be found out. But how about the polyamide, so nylon? How about wool? How about the elastane blends? So that's this is right now this is right now going on. That's and that we have not seen yet. We have no. That's an ongoing optimization. But if we already only go, the recycle the low-hanging fruits, means the cotton from pure, the textile from pure cotton, already that would resolve a lot. And then we have to go for the rest one also.
Mm-hmm. Yeah. So there was still some questions about the degree of polymerization of cellulose allowed for this lyocell 2.0. Are other properties comparable with standard lyocell, a part of linear density?
I think this is a question for Philipp. Yes, I read the question again. Please give me a second. Other properties is the properties being damaged in the viscose process, TTP? Yes, we are, or you are able to take a cellulose pulp with a higher degree of polymerization or with a lower degree of polymerization, you can play with it. But there is an optimum, let me say a dp of 650 units. This is an optimum cellulose where we can use it in the spinning dope with, let me say, 12 or 30% solid content, which makes them economically. When you use a pulp with a higher dp, then you have to reduce the solid content in the spinning dope, which means your output per hour is less compared to the standard pulp. If you use a pulp or a viscose fiber, for instance, then you can increase the solid content in the spinning dope, but you will get a fiber with less tenacity and maybe some of the cellulosic parts will be washed out during the process, or yes. I hope I get the question. Did I
Okay.
miss something?
I think you have answered it quite well already. Very interesting question for me because I'm working a lot also with natural fibers and with hemp. So there was this question was not raised. What's actually the advantage of making lyocell from hemp instead of spinning a yarn from hemp fibers?
Yes, the quality of the fiber. Um, of course, and it's very or was very common in the past. You use a natural fiber and make yarn from it and make clothes, apparels from it. But nowadays you want very high quality clothes, and for that and other processes afterwards, you need a uniform cross section, for instance. And the only way to get to a high quality fiber is to dissolute the cellulose and make a new fiber from it with a very uniform cross section, with a very fine linear density to come to a fiber, which is or
Uniform fiber.
yes, right.
Uniform fiber that can be upscaled. I think
Yes.
that is an important part. Yes, and then there's also some questioning about circ and circulose. Do we know if they can already work with lyocell to lyocell recycling? Is it a common knowledge?
I think you have to ask Circulose. I know it can be done. I don't know exactly. They have some specifics. I think that's probably also part of their competence, and to clarify, to really decide to select the properties, the textiles which they really can recycle. So in other words, I don't know. It's the, I think because right now they're focused, there are so many cotton out there and relatively few, the lyocell. So it's probably also part, as and blends in if you compare right now with we have a 4-to-1 of cotton to cellulose fibers, and within the cellulose fibers, 10% is lyocell. So it's actually it's a 40-to-1. So it's right now and not yet industrially relevant, probably.
Okay, so I think we have to move to the next topic. We have been talking now enough from this. This busting myths is something, of course, many of you know very many things about cellulose fibers, but the idea of this online format is that we also hope that we have succeeded to get people here that don't know so much about cellulose fibers as the experts here know, and that's why we are just testing some maybe funny questions already. So the first one is cellulose fibers don't cause microplastic. Is it true or false?
Yeah.
Who
Maybe
wants
I
to
can
take this
maybe I
one?
can answer that question or that myth. Yeah, this claim is not actually a myth at all. We just need to set the record straight here. First of all, regenerated cellulose fibers are man-made fibers, but they have nothing to do with synthetic fibers, no matter whether they are viscose or lyocell. After the regeneration process, and that's the reason why it's called regenerated cellulose, the actual fiber formation process, the cellulose is almost identical to how it exists in the nature. Why only the crystallographic properties differs from that in the nature. But however, this has no influence on their macroscopic properties, such as yeah, ability.
Gradability.
Yes, thank you, Manuel. So in this context, we can replace the word microplastic with microfibers or nanofibers, which are uh, also created like microplastic and synthetic fibers by abrasion during wearing or washing. But the main difference between both is for cellulose micro or cellulose nanofibers, there is no problem at all because these fibers are biodegradable, and therefore they do not remain in the environment permanently or cause damage to it. So yes.
We have a comment here. It says false. Only synthetic adders, chemicals, and dyes generate a microplastic. So of course you have dyes on that, and the people who was participating to our conference this year, the Cellulose Fibers Conference, we heard the topics there. Of course, we have to take care also about the dyes and additives, that they are also readily biodegradable as the cellulose is in different environments in sea and so on. So Philipp, do you know if we have the possibility to use such dyes and chemical additives that are biodegradable?
Yeah, sure. You can use such materials, but I guess the most people like bright colors and functionality of fibers, and therefore you need some additives. And yeah, Klaas is right. All these parts which are not cellulose can emit to the environment. But back again to the statement, cellulose fibers don't cause microplastic. I just want to mention cellulose fibers have nothing to do with plastics because it's a cellulose fiber which is inherent biodegradable. But of course, like all fibers during wearing or washing, you have a loss of fibers or emission of fibers in the environment. But in the case of cellulose fibers, the cellulose itself doesn't harm the environment. But you're right, Klaas, all other additives could be harm the environment if they are persistent, like pure chemistry based chemicals, for instance.
Mhm. Okay, so let's come to the next myth. So it says lyocell is the same as viscose.
Yeah, maybe I can answer to that too. That's a very common misconception, but as with the previous myths before, this claim is both true and false. You just have to clarify it properly. Based on the material, both fibers are cellulose, period, even if they differ in their polymer properties. So if you claim that lyocell is viscose, means cellulose is cellulose, then you're roughly speaking, that is correct at first glance. Um, However, the definition of both terms refer to the manufacturing or processes, which differs significantly from one another. In the viscose process, the cellulose must first be converted into another polymer, the so-called sodium xanthate, and the sodium xanthate spinning solution is then spun into a spinning bath of diluted sulfuric acid, which reforms the pure cellulose. In the lyocell process, however, the cellulose is dissolved directly without any chemical reaction, and the resulting spinning solution is spun into lyocell fibers made of pure cellulose in a water bath. The solvent can be recovered and used again as a solvent for lyocell. And yeah, this makes it clear lyocell is not viscose, even though the base polymer is the same. And yeah, these two differences make the lyocell process significantly more environmentally friendly and sustainable than the viscose process.
And what about the properties?
Of course, the fiber properties also differ, which means tenacity, for instance, for viscose is lower compared to lyocell. You can achieve higher tenacities with lyocell. Um,
And
the Yes, Asta?
Well,
biodegradability.
maybe in addition to that, with terms of tenacities, it's interesting that since this lyocell is that is a physical dissolving and it maintains the polymer, the natural polymer, the lyocell from recycled. That's the reason for the higher tenacities of lyocell from recycled cotton or recycled hemp, because they have also longer polymer chains, and that's why then with lyocell from hemp and cotton you can even increase the tenacity even further. And which is interesting because some of them you can even get in the air, in the air, you go towards tenacities which typically can also reach by polyester. So which
Yeah.
also means that we have to rethink, when with lyocell from hemp and cotton, it means that we can go into new applications, and so we think and also needs a change of thinking.
Mhm. And
And maybe another comment about the viscose. It's interesting to see. I met many people who thought viscose is plastic. They were surprised. Viscose is from cellulose. I didn't know. So I was surprised to hear that. Maybe it's just I'm too much into the topic, but I think it's worthwhile to communicate that too.
yeah, and of course also the biodegradability, that it is viscose is as biodegradable as lyocell is, but there's a difference in recyclability. Maybe you mentioned that already once, but maybe you can elaborate this a little bit more. Why is it different?
Because after spinning, the DP or the chains length of the polymer for lyocell is this same like for the pulp before. It differs maybe, let me say, 3 to 5% lower compared to the pulp you use for lyocell. For the viscose process, you start with a very high DP in the pulp, and during the process, you have to reduce the chain length of the polymer to bring it to a processable spinning dough. And therefore, the viscose fiber afterwards, the DP is much lower compared to the raw material or to the pulp.
Okay, so the next slide will bring us to the future of lyocell and cellulose fibers. So So, are you going to look at a crystal ball now? Who wants to start?
Well, maybe I start looking at trying to look at the crystal ball. Actually, I'm looking at the leads and on the projects which are going the way. And what I mentioned that the recent capacities in the last 5 years all have been built in China. But what's good to see is that there are now substantial concrete projects in Europe. So this means the green technology used by Lyocell allows now also the projects in Europe, and which brings back industry. So it contributes to the reindustrialization of Europe. And so there are projects out there, I think three, and at least three, which are specific and which are in the engineering phase. And this also is important because now we have lyocell technology, we have lyocell plants which we know can play a role in a circularity. So that's why it's also necessary, or also makes sense to have these plants in Europe, because then we can establish more local circles, the value chains. So basically, this goes into the direction, and it's a long way, but anyways, the direction is right to establish bring this technology back to Europe, so that we can establish local value chains, which means that we use then the worn textiles collected locally, and then we recycle it locally, so that we have the raw material which is local, and then we also can make this fiber locally. And then the question, of course, if then the textile industry is also local, or if then that these fibers go to somewhere to Asia, and then we become 5 t-shirts, and then we come back, and it's not that there yet, but at least that part is already important. Since also there are also dissolving wood pulp plants in Europe, so I think this is surely let's say a direction, a hope, or a good direction which is happening, although it's slow, but it's going.
Yeah, and the next slide will show how it's going to happen, because of course the extended producer responsibility, for example, now entering to force very soon. Every brand, every recycler, and every municipality in Europe need to rethink about how the textiles are collected, sorted, and reused. So there's a responsibility on European areas for that, and the member states will be in charge to take care that it's going to happen. And so I think there will be a chance for this local lyocell and cellulose fiber plants. And can you see here the fiber to fiber recycling going up? And can you maybe show some different kind of methods that can be used in this fiber to fiber recycling possibilities? I think that we didn't talk about that until today.
Well, the fiber to fiber recycling EU policy, and this refers to a regulation which is placed, or it's a decision on an EU level, which targets to implement fiber to fiber recycling by 2030. And as of now, I think it's barely not yet in place at all. I think there 1% a study of, I think, 2 years ago or so, which says that 1% of the fibers recycling is really established. However, there are large projects on the way, but the biggest capacities, I think 250,000 in Turkey, by the way, is the cotton recycling. So there's some cotton recycling, which is really a fiber to fiber recycling, which doesn't make the pulp, which then needs to be regenerated to lyocell, but it's the pulp. So this is also this is being installed, implemented, but this is limited to to more or less pure cotton, and then not to this cannot really deal with in particular also with the mixed textiles, and it shortens the cotton fiber. So it's not this it doesn't maintain the polymer chain on a polymer level, molecular level, as Philipp described it before. And so in other words, the big ambitions, we are not there yet, and we will first see an increase of the recycling of the mechanical fiber level, but we see now also on the chemical, and then a little bit delayed the chemical recycling, so like the circs and the circuloses. However, I think probably then the scalability will go up with the chemical recycling, because these are chemical plants. They need to have large capacities to be economical, and they're required due to the mixed textile problems. And then with the ability for and they are required for this recyclability of the physical dissolving of lyocell. So I think that's in terms of future bold, but it's not going to be by 2030.
Yeah. And we have here a question about from Markus Elmar. Hello, Markus. Are there any policies in place in Europe that helps European fiber production become competitive to China? I have heard in Dornbirn that EU will try to control all import that are too cheap, but this is still in planning, so it's not really not in place. But Europe is, of course, a lot of thinking a lot of the competitiveness of European industry, and they realize now that we need to do something for that. And if we are not allowed to export our recyclates, it also helps, of course, that new industries is coming up and helping to more make the circle in Europe. So is there something from your side, Philipp or Manuel, you want to say to this one?
Well, I think I think there's nothing which I can add. It's really one big problem is, how does the EU want to control the quality of the imported the textiles, so that there is not really that also the imported products follow the EU rules, and that's really not my competence. But yeah, you raised it. It's still not clear yet.
Yes, it's not clear, yeah. And we will see if Europe is going to succeed to help the industry somehow.
But however, maybe one comment was interesting to see that, of course, if you have global players, and they're also large, globally active companies, that of course on a company levels, these companies, big companies have also an interest to are say exposed to a certain let's say regulations or the legal actions of the EU. So this that's something but that is just personal opinion. What I see also here and there, that the large Chinese players also, some try not to get in and not to violate the EU rules, because otherwise they can also be punished in
very good
in Europe.
Chinese companies there. Are not only bad companies.
So. No, but it's yeah.
Yeah, of course. And the next slide will give us insights to market developments. I understood from you, Manuel, that you see investments in Europe in recycling plants. But do you see also investments to make new lyocell plants also in Europe?
No, my statement referred to lyocell plants.
Mm-hmm.
Yeah. The recycling plants also, as I said, there's those which are known. These projects are also coming. But a little bit they're less mature, other differently than Circ, which has of course been a big good news early this year.
Yeah, and Cirque is going to be in France, as the France seems to have more favorable regulative environment as it is in US, as Cirque is a US company, as far as I understood.
Well, yeah, I think, well, there are two things that there was actually under the Biden administration, there was this IRA. It's a regulation, it's called, I think, Inflation Reduction Act, but it was very much a tool to push, promote the green technologies, which of course has been, well, which has been cancelled on the first day of the Trump administration. Which also, but during that, while this IRA was in place, there was quite some concerns in EU also about competition from the US, because this IRA had the reputation to be very not complicated. And so, but this is over. That's why maybe not surprised that a US-based company, Cirque, actually ends up in Europe. Why in France? I think France within Europe, there are also different regional regimes, and France is seems to be very progressive in these regards.
Yeah, and they want to help their industry to stay in France.
Yes.
Yes, the next slide will take us already to takeaways for this event. But I see here one question about hemp sustainability for lyocell. And it is a question for both of you. Your opinion, please, on processing hemp fibers versus hemp hurd, chives, schäben. What would be better to use, the chives or the fibers for lyocell?
Yes, we investigate in the past both directions. We started with the hemp fibers because, yeah, the cellulose extraction is much more easier compared to the, yeah, wood-like hemp hurds or hemp chives. But yeah, the hurds are also very suitable for cellulose extracting. We investigate the extraction process and spinning process from it on our lab scale. And when it comes to the larger scale, which means also the extraction process in a larger scale, some, yeah, problems arise, which we didn't saw in the time. Uh, Simple things like how you can transport the chives into a huge digester. You need a specific mechanic to transport it upwards, and there was one problem. And another problem is you have to, or we have to investigate, is it yeah, economically, because you have to cook the chives a bit longer, and which makes the whole process in some more expensive. And then you have, yeah, make this cost comparison. But up to now, we know it is possible. Both raw materials leads to a pulp, which are processing to lyocell fibers or lyohemp fibers, or however you call it. And the properties are of these lyocell fibers with pulp from hemp chives or hemp fibers are very good. That's one.
So both fibers, either from chives or from fibers, hemp fibers is fine quality.
Yes, but what I know, the chives have another
Purpose.
Yeah, share of cellulose.
yeah, they are used for stables for your horses, and
They have very many applications. They can be used for horse bedding. They can be hemp for construction materials, hempcrete, you call that. So there's a lot of materials uses for these chives as well. Yes, it's used a lot.
right.
And what was your point, Philip? You afraid you don't get enough chives?
No, there are no. I want just to mention that point that chives are already used for different applications. And yes, you have to decide: is it from a financial point of view, acceptable to use chives for cellulose extraction, or yeah, point.
Yeah. I think chives are for sure cheaper as the fibers themselves because it's a byproduct of fiber production.
But the farmers get money for the chives.
Yeah, of course, but farmers get money also for the fibers.
But I think we have to be careful to discuss that to see that too strictly now, because as soon as you go to larger scales, you will have up a new masses, and then you have new production scales. Then you have different a different demands, so which is difficult to foresee now. But of course, I think hemp has a versatile use. And it's also interesting, but it's also interesting in terms of if it's ecological and it's very environmental friendly because it doesn't use much water. So it's also something which can be grown in Europe. It's also a possibility to establish local value chains in Europe. So that's why I think it's not as as immediate like the recycling, which is driven by regulation, but hemp is also an opportunity. So for our areas, geographical areas.
Yeah, and you can harvest it annually,
Yeah.
and wood takes many years to grow.
And it's it has no lignin, so lignin is whatever it really makes it's wood or makes less. So it's from that point of view, there are also advantages when it comes to pulping. So I think that's also something. So there's also a plus side for this for hemp. Yeah.
Yes. Okay. So when we think about key takeaways today for the participants, I would say it was wonderful to see this all kind of possibilities that cellulose fibers offer for the problem of huge amount of recycled textiles that we can use as a raw material, and we can see also that we can use also the agricultural fibers to make new fibers. We can do fiber to fiber, and yes, it was. Thank you a lot for this wonderful possibility to give you so many good insights in this technology. For maybe you want to say something. What was for you the key takeaway about this today? What did you learn about discussing with us and with the people participating, asking us, and what did you learn about the questions they was pointing out?
Well, I must say I'm very pleased and I'm very happy about actually how much interest this webinar raised, and based on the number of participants and also the numbers of many questions. And so I'm glad to know that I'm not the only one, and Philipp and I are not the only one dealing with that question, but they're also interested. It's a big, kind of almost a little community. So we'd be glad to have this to have further talks afterwards, and can be contacted, of course, to take that important topic further. Yeah, I think from that, this is what I learned from this webinar.
Thank you, Manuel. What about you, Philipp? What do you think?
Yeah, I like this format to be in a conversation with a partner to see the questions from the audience. I like it very much, and I guess that's the right way to be in contact and maybe to expand also the participants which are next to some value chains. So
Yeah, because there are a lot of different kind of actors along the value chain that can take the next chance to make the next Nova talk. So I would like to remind you that we have recorded this, and Nova has an own YouTube channel. So you can find this talk there, and then you can also listen to all the specific details you might not have noticed so quickly as Manuel and Philipp was talking. And the next slide will show you the persons that are working at nova-Institut with the Nova Talks. It's me myself, and also Michael Karus is also a great expert, and he might host the next Nova session. And Dusika Banduka was taking care of the marketing and organization of this session, and without her help, I think we wouldn't have such a huge audience today. And Guido Müller is the contact person you can contact if you already have an idea for the next talk. Maybe there's something you want to put on the table and discuss with the people, and then we would see the next Nova talk upcoming very soon, hopefully. So I see already, thank you there. This has been really insightful. Big hands for the speakers and Asta for discussing the topic. Okay, looks good. Okay, so it's time to say thank you for participating to this discussion with your questions. I hope you have a safe traveling home. And thank you also for our nice speakers taking all these questions and giving us such a good insights in the world of cellulose fibers, and hope to see you soon with the next cellulose fiber talk.
Yeah, thank you, Asta, for guiding us through these 1.5 hours and finding the right questions. Unfortunately, we couldn't answer all of them, but I'm sure that maybe the important questions will come to us anyways. We can discuss them on bilaterally later on.
Yeah.
So thank you for attention also from my side.
Yes, thank you very much also from my side.
Yeah, and we of course we want to also thank our partners for the publicity, textile technology, and want to say goodbye.
Bye.